In the last video, we thought of exponents as a way of counting numbers of factors. So if I were to have x to the second power times x to the third power, also could be stated x squared times x cubed, that would give us a total of 5 factors of x. We could just add the 2 factors and the 3 factors because we'll have a total of 5 factors. Now what we want to do is consider what happens when we have division. Now before we do that, let's quickly review what you would do if you had a problem like 12 divided by, let's say, 15. You had probably been taught to think of 12 as 3 times 4 and 15 as 3 times 5. And since the 3 is common to the numerator and denominator, they can cancel out or divide out, and you are left with 4/5. We can do the same thing with variables. So let's start with x cubed and divide by x once. If I have 3 factors of x in the numerator and divide by 1 factor of x, that can cancel out. One factor in the numerator can factor out with the factor in the denominator and leave 2 factors of x in the numerator, which would make sense to call x squared. The only caveat to this is we cannot do this if x equals 0. So we have to state x does not equal 0, otherwise we get a division by 0, which causes all kinds of difficulty. Let's consider what would happen if we took x cubed and divided by x squared. That would mean that we have 3 factors of x in the numerator and 2 factors of x in the denominator. So we could divide 2 of our factors out of the numerator using the factors in the denominator, and we would be left with 1 factor of x. Now we usually don't write this in, but it's always implied, if we just see x, that there is a single factor of it. So we could, in theory, write an exponent of 1, but no one ever does. Continuing onward, what if we had x cubed divided by x cubed? Now this gets a little trickier. The 3 factors of x in the numerator could be divided by 3 factors of x in the denominator, so each one could be canceled out. Now what we'd like to do as mathematically is say that we are left with 0 factors of x. Now it's pretty clear when you take something in the numerator and divide by the same denominator that this should in fact equal 1. But using the pattern that we've established, dividing 3 factors of x by 3 factors of x leaves 0 factors of x. So we could call that x to the 0 power, but acknowledge that that is 1. So x, remember, is a variable, so it could be filled in by a number, such as 5. If we have 0 factors of 5 that we're multiplying by, it would be equivalent to multiplying by 1. If we had 3 to the 0 power, that would mean we have no factors of 3 that we were multiplying by, and that has the same result as multiplying by 1. The only case we have to really be careful of if we have 0 as x. 0 to the 0 power is very ambiguous. We won't tackle that for now. So don't try this with 0 as the base of the exponent. Okay, so x is what's called the base, and when we substitute 5 in, we would say we have a base of 5 or a base of 3. You cannot use exponents with a base of 0. Continuing onward, what happens if we divide by something bigger than 3? So now I have 4 factors of x in the denominator and only 3 in the numerator. Well, this time, if we divide everything out, we are left with 1 factor of x in the denominator and none in the numerator. So the result would be 1 over x, or the reciprocal of x. But another way to think about this is, since we took 3 factors and divided 4 factors away, we have -1 factors of x. So what does the -1 indicate? Well, 1 factor of x means to multiply by it once. So the negative sign means divide by this many factors. So in this case, we would be dividing by 1 factor of x, which is the same as multiplying by 1 over x. If we continue, we could look at one last case, x cubed divided by x to the fifth. If we cancel the 3 factors of x in the numerator, we're still left with 2 factors of x in the denominator. But we can write this using negative exponents as x to the negative 2. So what does that indicate? It means divide by 2 factors of x. Now let's just consider a few examples of this before we move along. If we had 5 raised to the negative 2 power, what would that indicate? That would indicate that we want to divide by 5 2 times. Okay, so we could say that's the same thing as 1 over 5 squared. Okay. So another way to think about this is when you have a negative exponent, we could take the reciprocal of the number and use a positive exponent. Since 5 times 5 is 25, 5 to the negative 2 power is the same as 1/25. If I were to take another example of 3 to the negative 3rd power, that would be the same as having 1 over 3 factors of 3. So the negative 3 indicates that we would be dividing by 3 factors of 3, which would be equivalent to having 3 factors of 3 in the denominator, which would come out to be 1/27th if we were to expand that or simplify that. Let's look at a couple of other quick examples. Let's look at 10xy divided by 5x cubed y. So when we look at this, we can note, first of all, that 10 could be rewritten as 2 times 5. And then we have, use parentheses here to separate these out, 2 times 5. And then we have a factor of x and a factor of y in the numerator. We have a factor of 5, 3 factors of x, and 1 factor of y in the denominator. A factor of 5 in the numerator and a factor of 5 in the denominator can divide out. A factor of y in the numerator and a factor of y in the denominator can divide out, with the caveat that y is not 0. But now we have 1 factor of x in the numerator and 3 in the denominator. So let's simplify this. The integers simplify down to just 2 since the 5's divided out. But we are left with 2 factors of x in the denominator. So we could call this 2 divided by x squared. But that would be equivalent to saying that it's 2 times x to the negative 2 power. X to the negative 2 would indicate that we're dividing by 2 factors of x. Now be very careful with this. This is very different than 2. We indicate that this is not, whoops, mistake here. This is not 2x to the negative 2 power. If I had 2x to the negative 2 power, that would indicate that the entire expression 2x is in the denominator and being squared. So that would be the same as having 1 over 2x squared, which would be 1 over 2x times 2x, and we could simplify that to 1 over the 2 times 2 would be 4. Simplify to 4 since we can do multiplication in any order, and x times x could be written as x squared. So 2 times x, the quantity 2x to the negative 2 power is 1 over 4x squared, not 2 over x squared.